All right, so we did the ones where we were like kind of like plotting it, making the triangle the other day. So the stuff that's left, I was like, what's that? Anyways, just a refresher. That's where the angles have to be drawn when you do them touching the x-axis, not the y. But so we're backtracking just a little bit. It says to find the indicated function value if it's undefined, say so. So 52. All of these actually occur on an axis, so it's a little different. In the next section, we'll actually get into a little bit more, but 52 is the sine of 90 degrees. So we look at our unit circle, and I go to 90 degrees, and the sine is the y value. So at 90 degrees, I go up here and I look at the point. X is 0, y is 1, so that means that this is equal to 1.
Attention teachers, please wait for your classroom to be called before coming to the Bruin for pictures. Please wait for us to call your classroom to come to the Bruin for pictures. Thank you.
Let's see, 54 is the cotangent of 90 degrees. So we have a couple different ways we can think about cotangent. So tangent is y over x. I think I put that up on the board yesterday when we were doing the unit circle. So cotangent, we can think about one of two ways. We can think about it as 1 over the tangent, or I can think about it as x over y. So I would take whatever the x value is divided by the y value, and then that's how I get that. So this is probably the easiest way to think about it as x over y. So the cotangent at 90 is 0 divided by 1, which is just 0. Um, 58 cosine of negative 90 degrees. So obviously we have all positive angles on our unit circle, but I can also count backwards, which is what gives me negative angle values. So negative 90 would just be going down this direction, so it would be the same as 270 degrees. And we're dealing with cosines, that means it's the x value, so it's going to be 0. So we can think about this, if we need to, as the cosine of 270 degrees, which is 0. Just the x value there. Let's see, 60 is the tangent of 450 degrees. So tangents are what we wrote on the outside. My only problem is the ones that I have filled out that I laminated. Anyways, I don't have the tangent values on the axes here. I don't really know why I didn't put them. But anyways, I never redid them. So tangent of 450, so we go all the way around is 360 degrees. Well, I can keep counting and go farther. So another 90 degrees would be 450 degrees total. So this would be the same as the tangent of 90 degrees. And since it's not on mine, what is the tangent of 90? Yep, it's undefined because it's y over x, and it would be 1 over 0, which is just undefined. The last thing that's in this section is just kind of it says to use the trig function values to evaluate the expression. So 72, the tangent of 0 degrees minus 6 times the sine of 90 degrees. So basically we're just replacing the trig functions with another number, and then we'll simplify it down. So what is the tangent of 0 degrees from your unit circle? 0. So this is just 0 minus 6 times what's the sine of 90. So what's the y value at 90? 1. So this just ends up being negative 6. So nothing too crazy. One more of these ones. 76 is 5 sine squared of 90 plus 2 times the cosine squared of 270 minus the tangent of 360. So something they point out in the instructions and just something that we should be aware of is that anytime we have a trig function being squared, so like sine squared of 90, that is the same as the sine of 90 squared. Okay, so, but notation-wise, it'll be written like this, like most of the time when you see it. So, but this is what this means. So, 5 times, what's the sine of 90? 1. So this is just 5 times 1 squared. Plus 2 times, what's the cosine of 270? So what's the x value at 270? 0. So this is just 0, but I'm just going to write the square just so we see it. And then what is the tangent of 360? 0. So this just ends up being 5 times 1 because everything else goes away. So this is just 5. Any questions on this stuff? And this probably looks like super easy. I don't know. Maybe it does. Maybe it doesn't. But eventually, I promise we're going to get into ones where you actually have to use like the root 3 over 2, root 2 over 2, all those fun things. This is just kind of like let's ease you into it a little bit. So, let's see. I don't know where I guess I gave you problems. Did I give you problems? Yeah, I did. I'm just going to go up here and tack these on. Additionally, we've got 55, 59, and 75. So, nothing too crazy to add. But y'all you're welcome to stay here and work. If you want to go help the rest of your class with Valentine's, you can do that too. I don't care.